Hello, everybody. In today's lesson, we're going to talk about significant figures or significant digits. And we're going to start our discussion off by looking at making measurements with measurement tools like a ruler in this example, and how we appropriately record measurements using a measurement device depending on its smallest marking. So to start out here today, we've got a ruler. You'll notice that this ruler has markings every 0.1 centimeter or a tenth of a centimeter. So here's 0, here's 1 centimeter, and we have markings on the measurement tool at each tenth of a centimeter. This is really important when we go to make a measurement with this device, because in science we always want to measure one place past, one number beyond the smallest marking on the measurement tool. So for this particular ruler, since the smallest marking is a tenth of a centimeter, we're actually going to make our measurements to the nearest hundredth of a centimeter. We're going to estimate one place past the smallest marking on our ruler, on our measurement device. So in the example that we have here, I'm measuring an arrow. So let's go ahead and sort of mark the position of our arrow on the ruler. There we go. That's about where we want to be. Now we notice that the arrow is at least as long as 0.8 centimeters. So here's 0.5, 0.6, 0.7, 0.8 centimeters. It's somewhere between 0.8 and 0.9. Now, to measure correctly with this ruler, we need to estimate one digit past that smallest marking, which for us, we know the arrow is at least 0.8 centimeters long. So we need to decide, is it 0.81, 0.82? What is that estimated digit? Now, looking at the position of our arrow, if this is the halfway point between 0.8 and 0.9, we know that we're less than that halfway mark. We're closer to 0.8 than we are to 0.9. So it would be reasonable then to make a measurement somewhere between 0.8 centimeters and 0.85 centimeters, or in other words, 0.80 centimeters and 0.85 centimeters. And I'm going to say that this is about 0.82 centimeters. Based on the smallest marking on this ruler, I need to estimate that hundredths place. That 2 in the 0.82 centimeters is my estimated digit. And then this measurement would have two significant figures as a result. 0.82 centimeters has two significant figures based on the smallest increment of the ruler. Now, we did estimate that hundredths value, the 2 in the 0.82, so we would want to give some sort of indication that that value is an estimated value. It is not a known value. And to do that, we indicate uncertainty in our measurement. So since the 2 is the value that I estimated, sometimes what we would do for uncertainty would be to add to our 0.82 centimeters plus or minus 0.01 centimeters. So that's saying that that 2 is the estimated digit. Maybe it's actually a 1, maybe it's actually a 3, but it's likely within 1/100th of the estimated value. So that would be expressing uncertainty. So what we want to take a look at next is recognizing significant figures in a word problem. So if you're given a number of different measurements in a word problem, how do you recognize significant figures? And there are a handful of rules out there for recognizing what figures are significant in a recorded measurement. The first rule is pretty straightforward, and that is that all non-zero digits are significant. So you have a measurement, you have non-zero digits, all of those non-zero digits are automatically significant. So for instance, if I had a measurement of 333 meters, that measurement is going to have 3 significant figures. It has 3 non-zero digits. All non-zero digits are significant. that measurement has 3 significant figures. So that's the easiest of the rules for recognizing significant figures, just to realize that non-zero digits are always going to be significant. And it gets a little bit trickier from there in determining whether or not zeros will be significant. So let's take a look at the second rule then for recognizing significant figures. This is referring to zeros between non-zero digits. These zeros will always be significant as well. So zeros between non-zero digits are significant figures. So let's take a look at an example of what this might look like. Let's say we had a number 20,017, let's say feet, measuring distance here. So looking at the sig figs, immediately we recognize the non-zero digits 2, 1, and 7 as being significant. So we have at least 3 significant figures or digits in this measurement. We then have to consider the zeros. And the 2 zeros in this measurement are in between non-zero digits, in between the 2 and the 1. And so those zeros then also would be considered significant. And in total, we would have 5 significant figures in that measurement. Sometimes this is referred to as the sandwich rule, where you're making a sandwich with your zeros and the non-zero digits would be the slices of bread. What about zeros that do not fall between non-zero digits? How do we determine whether or not those zeros are in fact significant? So we do need more rules here. Rule number 3 deals with trailing zeros. So these are zeros at the end of a number. Oops. We're looking at trailing zeros in a number with a decimal point. So this would be an example of a number like 2.100, and let's say that we're measuring mass, so it's 2.100 grams. There are 2 trailing zeros that we see here, numbers the 0 digits that are at the end of our measurement here. Trailing zeros that are in a number with a decimal point are always going to be significant, whether they're after the decimal point or before the decimal point. So in this case, all 4 of those numbers are significant. You could also have trailing zeros that come before the decimal point that still would be significant. So if this had been like 2100.00 grams instead, we have 4 trailing zeros, and because there's a decimal point in the number, all 4 of those trailing zeros are significant, so we would have 6 significant figures in that measurement. Next up, we want to look at placeholder zeros. Rule number 4 helps us determine whether or not placeholder zeros are significant. So this would be a case where you have zeros at the end of a number, or for a decimal, for a very small value at the beginning of a number. Placeholder zeros are not significant, never significant. So let's look at a couple of examples here. Let's start with 20,000 feet. Now notice there's no decimal point in this number. So these are trailing zeros, but they would not follow Rule 3 because there's no decimal present in the numerical measurement. And as a result, these are considered just placeholder zeros, and they are not significant. So the number of significant figures then in this measurement would be 1. Only the 2 is a significant figure. The zeros are not significant. Let's consider another example of placeholder zeros. Let's look at a decimal value. Let's say we have 0.002300. So in this case, we have 3 placeholder zeros. But they are leading zeros this time. They come before the non-zero digits in the number. We also have 2 trailing zeros, but those trailing zeros after the decimal place would be considered significant in accordance with rule number 3. So when you have a decimal value like 0.002300, the leading placeholder zeros are not significant, but the trailing placeholder zeros are. So if we're counting our significant figures in this number, the 2 and the 3 because they're non-zero, and then the zeros that follow, trailing zeros with a decimal, rule number 3, are all significant. So we would have 4 significant figures in this measurement.